Hi everyone. In this video, we will see a basic mechanism for pressure-based dispenser pump. Let's understand the mechanism first. Initially there will be some liquid accumulated in the chamber, between the ball and piston. As the tube is pushed down, the spring gets compressed and consequently the ball is pushed, which closes the chamber. The liquid has only one escape path through holes in the tube, and thus liquid comes out of tube. The tube is forced to go up due to spring action. The stoppers are on the tube such that the holes of tube are covered by piston. Due to expansion, vacuum is created in the chamber. The liquid will be sucked from the bottom due to the pressure. The liquid will push the ball, as the spring is not under tension. Let's start. Open a new part document. Select the front plane and create a sketch. We will first create a master sketch of assembly. First, starting with the ball of valve of diameter 10 mm. Now, creating some construction lines to define the outer side of chamber. Follow the dimensions as shown in the video. Creating a tangent line, for lower face of chamber. Now, creating horizontal lines, to define the positions of tube, piston, and travel of spring. The first line is the tube of bottom, which is also start of spring. The second line is the end of chamber. And the third line is upper limit of tube. We will save the file as master sketch. Select the front plane, and create individual sketch for the chamber as shown. Create offset of the sketch. Again, select the front plane and create sketch for the tube as shown. Lastly, creating a sketch for piston. Follow the video as shown. Subscribe to the channel. And stay tuned for upcoming videos. Save as the file, as chamber. Use the chamber sketch, and create a revolved feature. Open the master sketch, and now save it as tube. We will slightly modify the tube sketch. First, we will add a stopper to the tube, which will define the topmost position of tube in the chamber. The tube is closed from inside, where the top of spring rests. Creating a sketch to close the tube. We will also move the lower part of tube a little outwards. Using tube sketch for revolved feature to create solid tube. Now, we will create holes on the lower part of tube. The liquid will flow through these holes when uncovered by piston. Using circular pattern on the feature. Again, We will open Master Sketch and now save it as piston. Using piston sketch for revolved feature to create solid piston part. Lastly, we will create a new part and make the ball. Open a new assembly. We will create the spring within this assembly. Insert the chamber. Insert in tube and piston also. Chamber will be fixed part, make it floating. And mate it with the origin of assembly. Fix the chamber again, and change its transparency. Now mate the tube with the chamber as shown. We can lock the rotation of concentric mate. Now mate the piston and tube. Lastly, mate the ball with chamber. We can now visualize the motion of tube in the chamber. Manually drag the components to set piston and tube to its topmost position. Changing the transparency of piston as well. Hiding all the sketches from the assembly as shown. Saving the assembly. Now, we will create a dynamic spring between the tube and the ball. Isolate the tube and ball for convenience. Select new part in Insert Components. Select front plane for sketch. Create a line connecting the ball and tube as shown. Change the assembly transparency. Try to mate the start point of line to the ball's curve. Now, create a sketch on front plane of new part. Create a small circle, corresponding to diameter of spring wire. Finish the sketch, and view all the sketches. Create a swept boss feature as shown. Select the circle sketch. And the vertical line sketch. In Options select Specify Twist Value under Profile Twist, then select Revolutions under Twist Control, and specify the number of revolutions. Exit the Component Edition mode, and rename the part. The initial position of ball should be a little elevated from the chamber bottom. We will suppress the mate, and move the ball upwards. We see that as the ball is moved, the spring rebuilds itself to updated shape. Save the assembly and the spring. Save the spring externally as shown. Let's go to Motion Study now. Drag the time bar at 2 seconds. We will define the bottom-most position of tube. Manually dragging the tube to its bottom position. Calculate the tube's motion. Now, slowly dragging the time bar, to determine the time when the tube should push the ball down. Place the key for ball at that time, to fix ball's position. Then, drag the time bar at time position, where the tube will start to push the piston down. Place the time key for piston at this instance. Also, placing the key for ball at this time, wherein the ball will touch the bottom of chamber. Move the ball manually to bottom. Calculate the motion again. Similarly, drag the time bar, and place the key for piston for defining its bottom position. The initial pressing animation is done. We can change frames per second in settings for better animation. Now, drag the time bar to define the assembly to its initial position. We will copy the key of tube from its initial state, and paste it at time 4 seconds. And calculate again. Similar to the down motion of tube, we will analyze up motion of tube, and place the key for ball as shown. Placing the keys for piston, at the point when the tube touches the piston from bottom. Calculate and view the animation. We can also create section and view for better visualization. Thank you. Subscribe to the channel and stay tuned for upcoming videos.